This video is about changing parabolas from general form to vertex form. We're going to be using a technique called completing the square. This technique is also in your textbooks, so you can go there for a reference as well. The technique that I'm going to show you is slightly different than what you will find in your textbooks. I do it a little bit differently. Some people like this technique better, but you're welcome to use what's in the textbook. It's all based on what you understand the most. And since we've looked at using vertex form before, I find that it's easier to change from general form to vertex form and then go from there about what you know about quadratic equations. So general form is when the equation is in the form y equals ax squared plus bx plus c. So your equation is in this form, and we're going to change it to the vertex form, which is y equals a times x minus h squared plus k. So we're changing from general to vertex form. We're using the technique called completing the square. Our first example is looking at y equals x squared plus 6x minus 8. We're starting with a very easy example to start with. The first thing that we want to do is to get rid of this minus 8 and get our x terms isolated on one side of the equal marks. So just like using solving equation techniques, we're going to add 8 to both sides of the equal marks. Whatever we do on one side, we do to the other. So we get y plus 8 equals x squared plus 6x. The next step requires us to do some thought process in our head. I'm going to come over here to the side and write down the steps that we are thinking in our head to get to the next step. So the first thing that we do is we take the coefficient of the x term, 6, and we're going to take 1/2 of that 6, which in this case gives us 3. The next step is to take the 3 and we're going to square it. And so when we take 3 and we square it, we will get 9. And then we're going to add that to both sides of the equation. And so these are the steps that we will follow each time when we're using completing the squares. And we just kind of think through those steps in our head and then come back to the equation to actually do that. So that's where the 9 comes from that we would add to both sides of the equation. So notice we have like terms on the left side, so we are going to combine them. So 9 plus 8 is 17. And then on the right side we have x squared plus 6x plus 9. Now the reason this is called completing the square is because we have purposely made this trinomial to be a perfect square. We're going to factor it. Now just refresh your minds about factoring. Remember, we would find two binomial factors. So remember, x squared means we'd have x and x. The square root of 9 would be 3 and 3, and the two 3's add up to be 6 in the middle. Because that's a plus, these would be plus here for each of those factors. Now, since these factors are identical, we can rewrite that as x plus 3 squared. So we really don't have to know that these are two factors. We should know that this is a perfect square and factor that as x plus 3 squared. We're just going to bring down the left side, y plus 17. Now we're going to get this back to just the y on the left side, so we subtract our 17 from both sides. So we have y equals x plus 3 squared minus 17. And now our equation is in vertex form. So all the things that we could identify previously from vertex form. Our vertex is at the location -3, negative 17. This means that our axis of symmetry is at the location x equals negative 3. It means the shift of the graph, it has shifted to the left 3 units, and it has shifted down 17 units. All of those things are things that we can identify from the use of the vertex form. So what we have just done is changed this equation from general form to vertex form. We've used the technique completing the square. We did our example equation y equals x squared plus 6x minus 8 and got it to the vertex form y equals x plus 3 squared minus 17 so that we could identify the vertex, the axis of symmetry, and its shifts.